what we're going to do is we are going to use the calculator to help us out on these. Because here's something that some of you, I think, are going to find might come in a little bit handy. Okay? On every one of these, my first thing I'm going to do is I'm going to look at the restriction they give me. It starts at -2. So here's what I'm going to do with this. Let me scooch this over a bit. Okay, I'm going to get a chart set here with x and y. Whatever value I have for x, I'm going to put in the middle. Okay, so since it's -2, for this particular one, I'm going to start with -2 in the middle. And then I know I'm going to have values on both sides of it. So I'm going to do some values that are less than my -2, and I'm going to do some values that are greater. Now, here's the part that I'm going to have to pay a little bit closer of attention to, because I don't have to find all these values for both of them. So for instance, okay, let me get, okay, so we'll get our calculator up here and working. Here's how this goes. I'm going to type in my first equation. So I got x plus 5. And I know what that looks like on a graph. Okay, there it goes. But if I look at my chart, let's figure this part out first. If x is less than -2, okay, so besides at -2, what other values am I going to be using? Well, I'm going to be using the -3, -4, -5, because, well, that's where the x values are less than. So I'm like, okay, let's go up here a bit so I can get the values that I'm looking for. So I'm going to go multicolor on you here, and I'm going to do a little bit of, I'm not going to use this whole box. So for when I do x plus 5, let's do this. I'm going to separate on this first one. Oh, except I'm behind it. There we go. So like we were just saying, we know we're going to use -2, but we also want to use some more values that are less than -2. So I get those written down, and those are the ones I'm going to put in my chart. So I've got -2, 3, -3, 2, -4, 1, okay, and -5, 0. So this is one nice thing about doing it with the calculator and using a mini chart. I don't have to worry about erasing and what do I erase and where do I start. So what I'm going to do is I'm going to plot these points. So -2, 3. Now be careful. On my -2, 3, is my dot going to be open or closed? Open, because there's no or equal to. Okay, so we're open dotted there. Oh, gracious. Okay, let's get the calculator out of the way. Sorry about that. So we're at -2, 3 with an open dot because we had no or equal to. And then I'm just going to plot the other points. So since x is less than -2, I'm starting at -2 where my open circle is, and I'm just drawing my line from there. But we always start our line from whatever value they have for x in us in the problem, in our restriction, okay? I'm going to do the same thing, because now in retrospect, I think doing these separately is going to do us much better than trying to do them all at once. Again, I'm going to be starting at -2, but this time my x value is greater than -2. So I'm going to be going to the right. In other words, I'm going to be adding 1 to my value each time. So I'm like, okay. So once again, we'll play the juggling game here with getting it on the calculator versus not being in the way. So we just go back and we go, okay, I've moved down to the bottom one now. So negative 2x minus 1. And again, I just want the values that I have here in my chart. So now I got to come down this way a bit. There we go. So at negative 2, we've got 3. At negative 1, I've got 1. 0 is negative 1. And 1 is negative 3. Uh-huh. So as I say, if some of you are having issues with, okay.
And then there's like a smiley face written in
So what we're gonna do, all right, I had to clear that out, but you should work now when you get it typed back in there. So here's our dilemma. You're like, there's a dilemma? Yes, because when I go to negative 2, 3, you're like, wait a minute, I already have an open circle there, but this line tells me it's gonna be a closed circle, so what happens? Closed circle will always trump open circle. So I'm just going to go ahead and I'm going to color that in. And now I'm going to plot my other points. So negative 1, 1, 0, negative 1, and 1, negative 3. And connect the dots. So as far as graphing it goes, that's it. But again, the key here is just realizing my graph starts at this number. And again, going to a chart helps me organize, and I don't have to think about where do I erase, where do I don't, and how is it working. Now, as far as the other parts go here, okay, is it a function? Remember, this is going to be the vertical line test. When we put that vertical line in somewhere within our graph and see if it goes through at more than one point. So I mean, let's say that's my vertical line and I'm going through. Well, it only seems to go through that one point. Or if I move it over to the axis, it only goes through at that one point. So it looks like we're good on this one. It's a pass. But then when you get to these, this one? Now that's a good question because we'll get into one again in a little bit where you'll see it where they're literally split apart. But since this one has an open circle, the open circle means I'm not including that value. So I'd be right up to but not. But yeah, so it's still only going to be one, but that's a really good question. But when we get to some of these, now doing a chart's nice. For instance, I'm going to skip this one for just a second. F of negative 4 means when x is negative 4, what's the y value? Well, if I got a chart, I can just write it down. If I didn't have a chart, I'd have to go back and look at my inequalities and say, well, negative 4, where does this fit? Well, it fits here because negative 4 is less than negative 2. So I'd plug it into this guy. Negative 4 plus 5 is 1. So it works either way, but the chart's just kind of nice because you just look and you go, oh, that's the answer. Negative 2 is 3. Okay. But wait a minute, I don't have this one. I probably could figure it out if I followed my line down, but what about it otherwise? So again, look inside the red box for a minute. If I plug in 3 for x, which one works? Because only one of them will. The bottom one, because 3 is greater than negative 2. So if I had to, since the bottom one works, I would just plug in the 3 where the x was and figure it out.
How do you know which one you use?
Because here, if I plug in 3 up here, is 3 less than negative 2? So, right, whichever one of these holds true when I plug the number in, that's the one that I'm going to use. Okay? So here I'd have negative 6 minus 1 is negative 7. So you can use the graph, you can use the chart, or you can plug the number in once you see which way it's going to go. And that's how all of these are going to work. Now, I threw a couple on here that are kind of odd. They still work the same way, though. Okay. So let's do one more specific one, and then we'll see kind of how we're doing with things here. So I'm going to flip over to number 4, because number 4 is weird. You're like, oh, now there's 3 of them. Lovely, lovely, Harty. Okay, so here's how we're going to do this. We're going to do it just like we did the last one. I'm going to make a little mini chart for each of these. And again, x is less than or equal to 0. Okay, we're starting at 0. Less than means my values are getting...
Do we have to do the chart?
No, if you're comfortable just drawing the line and erasing the other part, I say go for it. Or if you even can just get it on the calculator, then look at some of the values. That's fine too. But I just like this way because it lets you visually see what's going on, but it also gives you a backup plan here. So like for instance, if you just wanted to plug those values in, you could.
Can you do one where we don't? Or
Yep.
We just like erase?
Yep, I absolutely can. I'll do this one with it, and then I'll do another one where we do it that way. So like for instance here, I'd have negative x plus 4. And I want 0 and negatives. Okay. So 0, 4, negative 1, 5, negative 2, 6, negative 3, 7. And there's a couple of things that
I don't know what you have this student, so I wanted to give it back to you. Because I don't know
Okay.
if the student takes it next.
Got it. Thank you. So here, at 0, 4, yeah. Right, but remember, I'm plugging the negative in, that negative's still going to be there. So like if I'm plugging in negative 1 for x, I'm really doing, yeah, the opposite of negative 1 plus 4, and 2 negatives will make that plus. I'm glad you said that because that's good to get on here too. Because sometimes it is. It's easy when you see the negative to just think it's that way. So is my dot at 0, 4 going to be open or closed? Closed, because it's or equal to. Okay, so we got a big old closed dot here. So then I'm going to plot my other points. Negative 1, 5, negative 2, 6, negative 3, 7. Connect the dots. Here's where the weird part comes in. You're like, ooh, now there's a range. So what's that going to do for us? Well, let me tell you. What's going to happen here is I'm going to go ahead and still get my equation plugged in here. Make sure your 2/3 is in parentheses, because if it's not, you're going to get some funky looking stuff. So 2/3 in parentheses, x minus 1. The x is just pressing this button next to alpha where x is the first letter. That'll get you set there. And what I'll do is I'll shift this over here for a moment. So second graph. Now it tells me where I'm looking for my values. Now that's kind of nice actually. So when I'm doing 2/3 x minus 1, I don't have to figure out what the values are. I just follow what it tells me. Okay, I want the values between 0 and 5. You're like, holy cow, that's a lot of numbers. It can be on some of these. But here's the nice thing. The calculator's going to do all the heavy lifting for us. And there's some decimals even in there, which makes this even better. And we don't have to put all the decimals. We're just going to get some in. So once I get those jotted down, basically all I'm going to do is copy those points down and connect the endpoints. The only thing I have to watch for is what's open and what's closed. So for instance on 0 at negative 1, that's going to be open because it's just x is greater than 0. So I plot the other ones. And again, I'm not going to be perfect on my accuracy, but I should see something that somewhat resembles a line. And then when I get to my last one at 5, I see it's or equal to. So that's closed. And I'll connect the dots once I move the calculator out of the way. And the only thing I've got left at this point is this last part that says when x is greater than 5, the y value, because that's what these all are, is 2. Okay, 1, 2, 3, 4, 5. 1, 2. Open circle at 5, 2. And every x value after that is going to have the same y value of 2. Looks really, really funky, but that's what this one's going to end up doing for us. That one's set.
Why is it
This one, because x is greater than 5. It's not or equal to. The only time we color in dots is when we have the or equal to line underneath our arrow. Otherwise, they're going to be open. And the other reason, in this case it's open, is we don't want to have two closed circles at the same value. That wouldn't be a function then. So sort of like what Brad was saying earlier, it looks like when I go to see if it's a function, if I did the vertical line test, you're like, well, right there, there's 2 points. It's not a function anymore. But that open circle means we're not counting that value. In other words, we're taking every value right up to 0, but not 0. So we might be graphing at 0.0000001, but not at 0. So this is really only this colored in dot is the only point that's there. So this is still a function. Okay, all of these should be yeses for functions.
All of them, but I kind of like wrote down no as like from mistakenly wrote no.
Okay.
Because when I was trying to graph mine for number 1, it went like the opposite direction as of what was. So it went down and went up instead.
Gotcha.
I kind of like mixed up on it.
That can happen. Yeah, it's easy sometimes for a line to go the wrong direction and have something go a little haywire on us. That's all right. That's how we learn this stuff. And the nice thing about this is now, with everything, and basically I have points for every single spot, okay, f of -2, I can either look in my chart, oops, shrink, f of -2, I can either look in my chart and see that it's 6, or I could just go to -2 on my graph, 1, 2, 3, 4, 5, go to it there. Okay, hit 0, 1, 2, 3, 4, I agree. And at f of 5, looks like we're at this decimal, 2.33. That's how these work. Now again, I know in some places it's some extra work. You're like, I'm typing in the calculator, I'm jotting down these values. But again, it's about getting it right. So let's just say, now if some of you are, again, at this point, you're like, okay, I might have a hang of this. Try out a couple, oh, I'm sorry, go ahead.
For f of 0, wouldn't it be 5? Because is it anything multiplied by, oh no, never mind, I was thinking by,
That's okay. So here, try it with doing the graphs and putting in the charts, you know, and going that way. I've got a completed key sitting here on top of the projector. So maybe as you're doing it, you come up, take a peek. Yep, mine matches. Okay, or no, wait, mine doesn't match. Why isn't it matching? And kind of check that way. Because I am going to do one more, but since we had a request to have one done the old way, which is just draw the line and erase parts, I'm going to do one like that. But if you're feeling comfortable with the charts, I would keep charting. So let's try out number 5 here the old-fashioned way. Get my pencil back out. All right, so this one I'm going draw the line and erase. But I do realize we're going to be starting at 0 for both of these lines, but let's get them graphed first. So my first one, my y-intercept is at 1. So I'll get a dot in there. And then my slope is -1/1. So in other words, I have to go down 1 and right 1. down and right. And I want to go nuts with my dots because I want to make sure I cover every possible situation. And I can just erase whatever I don't need later anyway. Well, what if I need ones on the other side? That's okay. Instead of going down and right, I can do the opposite of both. Up and left. And I'm just going to keep doing that same pattern. All right, now I have a complete line of dots here. But which ones am I going to need? Well, let's see. So at 0, here's my x value of 0. So there's my dot. It says or equal to. So let's make that nice and filled in. X is less than or equal to 0. On which side of my dot are my x values getting less? Left, because if you were to number our lines, I'm getting into a worse and worse situation as I go to the left. The bigger the negative, think of it like money would be. It's like, ooh, I'm losing more money as I go to the left. So less than is left. So those are the ones I want to connect. And all these other ones to the right, well, they're just out. So I've got my first line. So one more time. Second line, we're just going to graph it first. We're not worrying about the restriction yet. 1, 2, 3, 4. Put a dot. My slope's -4/3. Ooh, am I going to have enough room? 1, 2, 3, 4. 1, 2, 3. All right. Let's go the other way too, just in case. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4, 1, 2, 3. Okay, that should do us pretty well. Kind of spread out, but I can still definitely tell they're in a straight line. So I look and I go, okay, we're starting at 0 here again, but this time it's greater than, and there's no equal to. So my dot on x equals 0 is going to be open this time, because that's how we signify that it's not or equal to. And which side am I drawing my line to if x is greater than 0? Let's try this. Right or left?
Right.
Okay, right. Because think about it. If x is greater than 0, or my x values, plug any of these in. Is 1 greater than 0? Yep. Is 2 greater than 0? Yep. Is 3 greater than 0? Yep. Negatives aren't going to be greater than 0. So I've got to go with the ones that are to the right, because that's where my x values are becoming greater than 0. And then consolation prize for the other dots, you get erased. That's what my graph would look like. And like I said, these are all going to be functions, because even here where I wonder, this closed dot is the only point that's on there. That one's open. So another yes-a-roo. And again, I have a choice. I can get my function values straight from the graph if I want. So like -4 for my x. 1, 2, 3, 4, 5. At 0, there's my closed-in dot. That's at 1. And I think we can even get 3 here. 1, 2, 3, 4, 5, 6, 7, -8. This one will be on the next homework check. That's correct. This will be assignment number 2. I should write that on here. Let me do that. Homework check for assignment number 2. And I'm just taking a wild guess. There is a distinct possibility that your next homework check might be the day of the test. We'll see. If not, it'll be the day after. It's going to be Tuesday or Wednesday.
Also, we haven't finished the one we didn't do that.
Correct. We're going to finish up the ones that you didn't do, and then if you get done or twiddling your thumbs, you always can go to that test preview and start messing with it a little, even though you will have some time in class tomorrow to work on it. We'll be able to start getting some questions, and then we'll go over it thoroughly on Monday, is the plan right now. So that's where we're at.